Okay, what do you guys think? Who's got this? If I told you to do it as a sine function, so y equals a times sine of kx minus c, and I noticed I didn't move it up or down, so there's no plus h. You could do plus h, but there is no h, 0. Okay, so first of all, a should be easy to find out. What is a, you guys? The amplitude is 3, so 3 sine. How many cycles do you see between 0, which is right here, and 2 pi, which is right here? You see half of a cycle. So what's k going to be? 1/2. Do you remember how easy that is to find that, you guys? Just count how many cycles there are between 0 and 2 pi for sine functions, cosine functions, secant functions, and cosecant functions. What would you count on tangent and cotangent functions? Yeah, you count. It's only pi, so between 0 and pi you would count. So halfway, right there. If it was a tangent or cotangent. Okay. Now, so that's k theta, and now all I have to do is shift it right or left a little bit. Pi what? Okay, pi halves. So minus pi halves or plus pi halves? Huh? Plus pi halves. Okay. What did I get? Let's see what I got. 3 sine of 0.5x plus pi halves. That's what I wrote. Okay. By the way, if I did this as a cosine function, what could have I put in here, you guys? What would I put in here if I was doing this as a cosine function? It's easier. No one knows? 3 cosine of what? 0.5 is still going to have the same k value, right? But you're not going to shift it either left or right. It's just going to be that. And it's going to graph the same things. You can't see it graphing because it's graphing over the top of that one. So those two are the same thing right there. Yes? The phase shift? Well, let me just do this because I showed you guys several times, but a couple things that happen in phase. Well, first of all, let me just say this. Any phase shift I will put in there will be one of these numbers right here. It'll be either pi 6, pi 4ths, pi 3rds, pi halves. It will probably be one of those 4 numbers. You can just try all of them. Yeah. It's going to be one of those numbers. I might shift it left or right. It might be positive or it might be negative. Could be a negative one of those. But every single phase shift is going to be one of those numbers. Now you could do things like 2 pi 3rds, 3 pi 4ths, and 5 pi 6. Or by the way, pi, that's another phase shift I might do. You could do one of those, but usually you can get that by doing the negatives of these over here, these 4. Okay? So I can't remember what I put on the test exactly. It might be any of those, but it's going to be in terms of pi, the phase shift, okay? So if you just do trial and error, you can see how far you're shifting in the direction you can get it that way. But you could always use this formula, phase shift equals C over K. And you can see, okay, how far did it shift over? And you can put that number in for phase shift. You already figured out K, so you can put in K, and then you just solve it for C, and you'll have it, okay? But unless you have a deep, deep understanding, that way is a little bit more difficult. And by this point, some of you don't. K changes the period. K affects the period. It affects it either going longer this way or getting shorter. Like on this problem right here, we expanded it. So now only half of a period takes place between 0 and 2 pi because we're taking a slinky and stretching it out, right? We stretched it. Yeah, if you stretch it, if K gets smaller, it stretches it. If K, you guys look, Yeah, you guys listen. If k is a number between 0 and 1, like 1/2 is, then it stretches it. It's like taking a slinky and stretching it out. If k is bigger than 2, it's like pushing it in, okay? It's like taking a spring and pushing it in. And c is the phase shift. It shifts it to the left and right. And so you just put one of these numbers in here to get it to shift to the right amount, and you'll have it. It's just playing around with it, okay? All right. Everybody try this problem right here. Find the function for this graph. Same window. I'm going to give you a second to find the window, right, or this. This is continuing our review that we did the other day. By the way, how many of you watched the review video? Raise your hand high. Keep them up. I want to see. Review video. 1, 2, 3. That's it? I did these 3 problems already on there. So what'd I say? Oh, from somebody walking by? What are you talking about? Okay, guys, first thing I'm going to do is figure out what k is. You guys, let me say this about k. K will always be, it won't be in terms of pi. It will be a number, it'll either be a whole number like 1, 2, 3, 4, 5, 6, or it will be like the halves that I did. I don't think I put any thirds on there. There possibly could be 1/3 or something like that, but probably 1/3, 1/2, or it's going to be a whole number. Got it? Okay, now I can count how many cycles. Okay, this is 2 pi right here. Here's 0. Halfway between there, 1, 2, 3, 4 would be right here, right? So I can count how many cycles take place between 0 and pi. There's 1, 2, 3 do, right? I have 3 of them, so I know that k is 3. It's that simple. Can you guys do that? And by the way, is this a tangent or cotangent? You could actually use either one. You could use a negative tangent, or you can use a cotangent. Okay? But y equals cotangent of 3x. Did it shift, or is that it? That's it. Now, how do I have to put that in my calculator when I put it in? 1 divided by the tangent of 3x. And there it is. Or I could put it in like this. Watch. I just told you. You could put it in as the negative tangent of 3x. I could do it that way. Oh, whoops. Oh, yeah, you have to phase shift it if you put it in that way. I forgot. Okay, 1. Well, let's see. How much would we need to shift it? Is it? Here's the correct one. Let's see if I got it on the next one. Looks like I got it. Okay, it was pi halves. Shifted at pi halves. Good. Okay. Yeah, because remember, right here, you guys, 4 lines, he said 4 tick marks over would equal pi, right? Because this is 0, this is 2 pi, so this is a 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi, which is pi, right? Right there. Got it? Halfway over is pi. How many, from negative 2 pi to positive 2 pi, how many cycles would you see if k was 1 on this? You'd see 4 of them, right? Because every pi units, there's 4. You see 4 pi. Between negative 2 pi and positive 2 pi, you see 4 pi. So you would see on a tangent function, on a normal tangent function that has k as 1, you would see 4 cycles. Yeah, because look right here. Well, if you have, because the normal, for a tangent function, the normal period is pi, right? Usually between 0 and pi, you'd only see 1 cycle, okay? But I see 1, 2, 3 cycles before I get to pi. That means k is 3. Do you understand that? 3.5 shouldn't work. 2.5, it will get close, but it won't be exactly on. 3, you have to do 3 to be exactly on. 2.5 is going to be a little bit off. Okay, let's do one more of these. Let's do that one. See if you can get that one. Hey, there's four graphing problems like this on your test today. It's not inverse. These are not inverses. These are reciprocals. 1 over, right? It doesn't matter. You guys, this one can be done as a cosecant or a secant. That's what you're asking, right, Ramon? Yeah, this one can be done as a cosecant or a secant. I would say the one that's the reciprocal of the cosine would be the easiest. Remember, you guys, remember these functions touch at the valleys and the hills right here? And since this is touching at one of its valleys right here, it's touching that thing right there. Remember, cosine function comes up at 0, 1 and touches right there, right? So what's the reciprocal of cosine? 1 over cosine, which is secant. I would use a secant. That looks right. Well, you'd want to see, you guys, it looks like there's an asymptote right here at pi. There's another one right here. Yeah, that looks like it's it. How many cycles do you see between 0 and 2 pi? Because the normal, you see half. So k is 1/2, right? What? Well, all you have to do is say, okay, here's 0 to pi. I see a fourth of one here and a fourth of one there. Secant, yeah. Huh? Okay. Right. Tangents and cotangents go to pi. Their normal period equals pi. But on sines, cosines, cosecants, and secants, their normal period is equal to 2 pi. So you count, to find k, you count how many cycles take place between 0 and 2 pi for those 4. You guys all got this? The normal period of a tangent cotangent function is pi. For these other 4, it's 2 pi. Andrew. Okay, let's count this one. Let me erase all this. Remember, a cycle would consist of one thing going up and one going down, right? So between 0 and 2 pi, you have a fourth of one there and a fourth of one there. That's a total of a half of a cycle. So it's k is 1/2. Does that make sense? Okay. We got it? All right. What did you guys get for this one? So 1 divided by the cosine of 0.5x, right? Or 1/2 x, however you want to write it. That should be it. Okay? Yeah. It's actually Humpty Dumpty. Yeah, see? Humpty Dumpty. There you go. All right. You got 4 syllables. We got to use all 4 of them, right? Okay, here we go. We're going to go on to a different one. That one. You can use a sine or cosine on this one, can't you? Whichever one you want. So it would be 1/2 x plus pi fourths. Did you do minus pi fourths? Actually, it probably doesn't matter. Yeah, you did cosine, you're going to minus. Yeah. Hey guys, if I did the cosine, I would minus. So like right here, if I go to this one, I can either do 2 sine of 0.5x plus pi fourths see if that does it. That does it, right? Okay, because it shifted. What it did is it took, okay, your amplitude was 2. Okay, there's only half a cycle that takes place between 0 and 2 pi, right? If you look over the whole thing, only one cycle takes place from negative 2 pi to positive 2 pi. So, and then I shifted it. Minus the negative pi force would be plus pi force, and it shifted to the left pi halves. Okay. However, if I did a cosine, this would be 2 cosine of 0.5x, but this time it would be minus pi force, because you've got to shift this one to the right, and it will graph the same graph. Okay? Kyla. How did I get negative pi over 2? Okay. Well, Kyla, like I said, I would just guess on the shifts, shifting it left and right. But let me just show you really quickly, and maybe some of you guys will get it this way better. Okay? I'm going to write in red this time. Did you use a sine or cosine? Your cosine. So here's my cosine curve, this blue one right here. Notice, to get it from here to over to there, I had to shift it 2 units. I mean, 2 of these tick marks, right? Well, each tick mark is pi fourths. So 2 tick marks is pi halves. Got it? So my phase shift is pi halves. Well, this is for the sine one. My phase shift is a positive pi halves equals c over k. Now, because I'm using this formula right here, right? Phase shift was pi halves. C, I don't know. That's what I'm trying to figure out. And k, I know, is 1/2. To solve this equation, I times both sides by 1/2. 1/2s cancel out, and I get c equals pi fourths. So I've stuck it in that equation. Y equals 2 cosine 1/2 x, and then minus the positive pi fourths, shifts it to the right pi fourths. Got it? But like I said, you guys on phase shift, if you're not sure, start with pi sixths, then pi fourths, then pi thirds, okay, then pi halves, and I just put each one of those in there and shift them. If those don't work, put them in negative. Change the sign. So that's what you do, okay? Yeah, pi sixths, pi fourths, pi thirds, pi halves. All you have to do is shift them. Keep trying them until you get the right one. Got it? Can you guys do this?
I have a question real quick.
Yeah.
How do you find out when you say like PS equals C over like whatever, and then you like do the math to find out what?
Okay, well, all I did right here is it's PS stands for what? And PS equals C over K. C is the number that we put right here, right? It's the number right there that you minus or add. And K is the number that goes in front of X, right? So first of all, I would count how many cycles take place between 0 and 2 pi on this one so I can figure out K. Then I would count the phase shift. I know that since here's the hump, and I'm using cosine, usually the hump's right here, right? So I shifted it over 2 of these units, which is pi halves. So that's why I put pi halves in there. I put pi halves is the same thing as ps. It's that right there. C I don't know, and k I know is 1/2. I put it in there, and I just solved it for c. Times both sides by 1/2 to get c by itself. And that gets you pi fourths, and that's how much you shift it. Okay? It'd be put in as minus pi fourths because that's how the equation's written, as minus. Because the phase shift is pi halves. But c, because you guys, when k is 1, then whatever c is the phase shift. But when k is a number other than 1, you change the period of it, and that changes the phase shift. And so phase shift and c are not the same thing. They affect each other, but they're not the same thing because whatever k is affects the period and the phase shift. So that's why k is in all these formulas. Yes. 13. 3 of them are extra credit. Two of the extra credit. I didn't ever teach you how to do any of the extra credit ones. So. I don't. If you watch the video, I told you where to look in your book for the extra credit problems. Angular velocity and linear velocity. You guys know the difference between angular velocity and linear velocity? That's because you had to watch the video to get it. That's what I should start doing. You guys, if you're on this merry-go-round, and there's a person here and a person here, person A and person B, and this merry-go-round goes around. Each time it goes around, who travels further, A or B? Well, but they both only went around once. If you're running on a track, do you want to be A or do you want to be B? Okay. B has a shorter distance to run, doesn't it? There's the difference between these two is linear and angular velocity, okay? Linear distance and angular distance. Because in linear distance, if you talk about linear distance, A travels farther, right? Travels farther than B. Does that make sense? But if you're talking about angular distance, they both turned 360 degrees, didn't they? In one turn. So in angular, A and B are equal. That's the difference between. Do you understand that? One's a linear distance, one's counting the angle measurement. Okay? Now, that's not the question, though. The question is angular and linear velocity. You have to figure out some problems. There's a formula in 6-2. I don't know if it's on that paper or not. I don't think it is. Yeah. Did you get that? Hey, you guys. In your book, I'll show you a page. Lesson 6-2. Tell me what page we're on, you guys. 352? Yeah, just a second. I'm gonna. Well, actually, who's moving faster? If you're going on a merry-go-round, are they moving at the same speed, or is one moving faster than the other?
But if they are going at the same speed,
think about this. When I was a little kid, we at Lagoon, they used to have this in this fun house that they had this thing where everybody would pile onto it, and then it would start spinning slow at first, and then it would start spinning faster and faster and faster, and it was the last person that stayed on, and then they had these pads where you'd fly off and you'd hit these pads, and the last person on won, and then they'd turn it off, and everybody would pile on again, and they would do it again. Well, where did you not want to be on that thing? On the outside. Who always won? the guy, inside guy, or the one that can throw the inside guy off, right? And so we get on this thing that spin around. You want to be closest to the center because center, you're going the slowest movement, right? The further you get out here, the faster you're going, and so centrifugal force is going to throw you off, right? And so we would play this game. Huh? I think they don't have, they did away with it because kids would get hurt. You know, they'd have these pads out here going all the way around. They'd fly out, and you'd hit those so hard sometimes. And I think because of lawsuits and stuff that they had to get rid of that game. No, you didn't have any bars. It was just it. And you would just get in the middle, and you had to try and hang on for dear life, and fight your way to the middle. That's what you did. And I only played it when I was a little kid, you know, 11. It's the oldest I was, and you'd get on with all those kids, and the last person on there would win. So I can't remember. We would go there and we'd play that game, but that's the difference between angular and linear velocity right there. The further out you are, the faster you're going, right? So the closer in, the slower you're going, because you got to cover, A has to cover that distance in the same amount of time that B has to cover that distance. So you got to go a lot faster to cover that distance. So anyway, they have these two formulas right here. The angular velocity formula is this little letter. It's called, I think it's called omega. Equals theta over t. Well, theta is the angle in radians, and t is time. So you can figure out a problem if you just know that formula. This is called angular velocity formula. This is the angular velocity formula. Okay? If you want the linear velocity formula, there's some extra credit problems on the test like this. If you want linear velocity formula, you could have, V equals, well, V equals, there's a couple of formulas you can use. V, which is linear velocity, that's what V stands for, is equal to the radius of the circle times theta divided by t, okay? Well, theta divided by t is omega, so you could write this as V equals R times omega. So you could write that formula if you want. And that's the linear velocity formula. Okay? So that's all I'm going to say about that. So if you write those two formulas down there, you might be able to, they're pretty simple problems I put on the test. You might be able to get a little extra credit. No, just if that's what the angle is. They'll give it to you. Oh, I'm not doing angular displacement. You're just doing. Well, angular displacement is the angle in radians. Did they give that to you as? They probably gave it to you on this problem as 2 pi. Yeah, because 1 revolution is 2 pi. Well, yeah. 5.2 revolutions, and each revolution is 2 pi radians, and so that's a total number of radians is going to be 10.4 pi radians. Yeah. Okay. I forgot to turn that off while I was talking. Okay. One other question, you guys. This you do need to know. Given an arc with a length of 12 feet and an angle of 30 degrees, find the radius of the circle. What's this problem about? Arc length formula. Do you remember? You guys have that written in your notes? S equals R times theta. S is the arc length. It's been a little while since we talked about this one. R is the radius. And last one, most important. Theta is what? Yeah, it's a measure of the angle in radians. Okay? It's the measure of the angle in radians. Do I give you the angle in radians on this problem? So what do you have to do? You have to convert it to radians. How do you convert 30 degrees to radians, you guys? You times it by pi over 180, or you can look at the unit circle on that one, 30 degrees. Yeah, I did. So that reduces to pi 6. You're probably going to want to put that as a I mean, and the radius is 12, right? Given an arc with oh no, it gives you the arc length. So we're going to put 12 in for S. 12 equals R times pi 6. And so you're going to times both sides by 6 over pi. 6 over pi. So you're going to cancel out. You're going to get R equals, what's 6 times 12 divided by pi? Put that in your calculator. It's going to be somewhere around 35. It is? Wait. Go 6 times 12. Okay. I'm thinking wrong in my head. I was just thinking, oh yeah, that's right. That's right. That'd be right. I was doing it wrong in my head. Okay, about 22.91 feet. Okay, so you watched the video too. You didn't raise your hand when I said who watched the video. Oh, okay. So 4 of you watched the video. That's good. 5. You 2. Oh, I thought you watched. Okay, watch. Okay. Okay, the inverse. Okay, write the equation of the inverse of each function, then graph the function and its inverse. Well, you guys, quite honestly, on the test, all you need to be able to do is calculate an inverse. You don't have to be able to graph it. So hey, you guys, let me show you the types of problems that are on the test as far as oh, by the way, do you guys want to do this extra credit problem real quick? Do that, and then I'll come back to the inverse problems, okay, in just a second. Determine the angular velocity of an object traveling around a circle given 1.8 revolutions in seconds.
I feel like we just keep going off on different things. I have no idea what that.
Well, these guys were asking me about the extra credit problems, angular and linear velocity. This is a extra credit problem. They're actually not too bad. I don't tell you how many seconds, do I? That was a mistake. I probably should put some number in there. I don't know where I got this problem, but we could say determine the angular velocity of an object traveling around a circle given 1.8 revolutions in, let's say, in 2 seconds. If we did it in 2 seconds, then the formula is angular velocity equals theta divided by t, right? Well, you got to determine what theta is. If you go 1.8 revolutions and each revolution is 2 pi, so you're going to go 1.8 times 2 pi to get your angle divided by 2. And whatever that number comes out to be is your answer. What does it come out to be? Huh? 5.65? 5.65 revolutions per second? Because is that what you all got? Yeah, Rachel. How far around a circle is 1 revolution? 2 pi. It went 1.8 revolutions, so we need to put that in terms of radians, right? 1.8 times is how many times it went around, and each time it goes around is 2 pi radians, so 1.8 times 2 pi. And that gives you that number, the angle, and then you divide it by the time, and you have it. Okay?
Wait, so what's
T stands for time. Hey, if you guys ever become a physicist or a mechanical engineer or a lot of different kinds of engineers, you're going to be studying rotations because anything that has something that goes around, wheels on a car, okay, anything, and a lot of mechanical devices goes around in circles. You'll be studying things like angular velocity and linear velocity, and you need to know about those. Theta is the angle in radians, and you get the angle in radians by timesing the revolutions by 2 pi. A revolution is once around, right? It goes 1.8 revolutions, then it goes 1.8 times around, and each time it goes around, it covers 2 pi, so you go 1.8 times 2 pi. All right, hey you guys, back to the question about inverses. If I gave you something, can I just look in your book where you? Let me just look at the chapter review. Hey you guys, everybody go to page 416 in your book. Page 416. Just really quickly, I have on there like the arctangent of -1. How do you calculate that? What is that asking? What angle has a tangent of -1? It's asking this. Tangent of what angle equals -1? All you have to do is go up the unit circle, and if you go right here, y divided by x, you're going to have a negative and a positive. You're going to get to negative pi fourths, you're going to get a -1. You can look at your table. If you look at your table, you just go to tangent, and you find -1 on there. Well, -1 occurs at 3 pi fourths, and -1 occurs at 7 pi fourths. What's the problem with 3 pi fourths? It's not in the range. Remember, the range is only the first quadrant and the fourth quadrant if you go in the negative direction. So 7 pi fourths isn't the answer, but that's where it's located. But you have to get there by going the negative direction, which is negative pi fourths. Okay, so the answer to this is negative pi fourths. Got it? Okay. I'm not gonna. Those aren't gonna be on the test. You know what? We'll turn that in next time. We don't have time to do it today. You guys, there'll also be one there'll also be one like number 25 and number 27 on the test. I'm gonna go 6-8. I'm gonna go to 47. I'm going to do 47 on page 416. Cosine inverse of tangent of pi over 4. First of all, you're going to start inside the parentheses. What's the tangent of pi over 4? Go to pi over 4. You can even look on your table.
1.
It's 1. So now it wants to know the cosine inverse of 1. And this is asking cosine of what angle is 1? 0 degrees. Because it's the x-coordinate. At 0 degrees, the x-coordinate's 1. So that's the answer. Got it? You just start on the inside. Figure out that one, and then go to the outside one and do that. And so the tangent of pi over 4 is 1. So I replaced it, and then I found the cosine inverse of 1 and got 0 degrees. Okay? Got it? We got to start the test.